So far, we've discussed a couple of important structures that we use for inheritance, one being interfaces and the other being superclasses and subclasses. Today, we'll examine one of the other major structures, abstract classes. If you look at circle and rect, which are the two classes that we've been looking at for a couple of lectures now, you see that there's actually a lot of duplication of code between the two. And inheritance provides us a way to reduce the amount of code that's duplicated between the two. So to do this, we're going to define a new class that is a superclass of both circle and rect and contains all the variables and all the methods that are common in both. Both circle and rect are just going to inherit all those common variables and methods from this common superclass. We're never going to have any reason to instantiate this class. So we're going to make it an abstract class. That just means a class that can't be instantiated. You cannot make an instance of an abstract class. Now, the classes that extend to this class and that are instantiated, we call those concrete classes. So there's a distinction. Abstract classes, which we don't instantiate, versus concrete classes, which we do instantiate. Now, it would be nice in this situation to call this new abstract class that we're making, just to call it shape, because that's a sensible common superclass of circle and rect. But shape is already the name of the interface that we were using, so instead we're just going to call it abstract shape. Now, it's convenient, although not necessarily totally required, to have abstract shape implement the shape interface. That means that circle and rect no longer need to implement shape themselves. They'll inherit it through abstract shape, which they'll extend. So because abstract shape is going to implement shape, it actually has to include all of the shape methods, which you see right here. Even those like area that are completely different in the subclasses, right? It's totally different calculating the area of a circle and the area of a rect. There's not really any common implementation code there. At least the methods are common, but the implementations are totally different. So if you have a method like that, for instance, area in abstract shape, where we can't really write any code, we'll call that an abstract method. And when we write our header for the area method in abstract shape, we're just going to include the word abstract as a keyword, and that will mean that we don't have to implement it here. Okay, it takes a bunch of code to actually implement all the classes, but the code isn't that hard to understand. Now, we especially want to watch for the attributes abstract and final here. And final means, final we use for the first time in a method definition in abstract shape. A final method is just a method that can't be overridden by any subclass. We'll see an example. Okay, so here we have the beginnings of our abstract shape class. You can see it's declared as an abstract class, and it implements the shape interface. We don't have to say that it extends object because that's just the default. All classes by default extend object. So here we declare a bunch of variables that are going to be common to all subclasses. The subclasses themselves will add their own instance variables. For instance, circle will add a radius, and rect will add a width and a height. We'll have a constructor, and even though we're never going to actually instantiate an abstract class object, we still have to have constructors that initialize the variables. And you can see we have an overloaded constructor there as well. The next two methods, area and draw, are both abstract methods. And it makes sense to make them abstract because their actual implementations aren't shared between their subclasses. A circle will calculate its area and draw itself completely different from the way a rectangle will. So we declare these methods abstract. Now, the order of the keywords here, public and abstract, doesn't matter. Okay, you could declare it public abstract, you could declare it abstract public, doesn't matter. But the fact that this method is included in the abstract shape class and each of these methods is declared as abstract means that subclasses have to define those methods. So whereas it's abstract in this class and there's no implementation, subclasses have to define them. The next few methods, getX, getY, and move, those aren't actually going to change in any subclass, and we don't want them to. So we declare these as final. And declaring them as final means that none of the subclasses of abstract shape can override those methods. They're stuck with this particular implementation. Okay, we're still in abstract shape. Here's another abstract class that we'll force a definition for in the subclasses, stretch by. Okay, stretching by a factor for a circle and a rectangle are different, and we acknowledge that by making this class abstract and not bothering to try to implement it here. We just say, you know what, we're going to punt on this, and the subclasses need to define it themselves. Now, if you take a look at this last method here in abstract shape, toString, we don't declare toString as final because we want other subclass methods to be able to override it with something specific to themselves. So it is defined here, but subclasses will be able to write their own versions of toString and override it. Okay, on to the circle class. We can see here that we are extending the abstract shape class, that abstract shape class that we defined just a moment ago as a common superclass of circle and rect. We're adding a new instance variable. This one will be protected, radius, and we do that on purpose because we know that we're going to define a wheel subclass, and we want that wheel subclass to be able to access radius. So we make this protected. Perfect. Make a constructor. This is the noarg constructor. It calls abstract shapes constructor to initialize x position and y position, and then we initialize the instance variable unique to circle right here. Likewise, we have a constructor that takes more parameters, x location, y location, and radius. You can see here we implement draw, which was in abstract shape an abstract method, meaning that subclasses had to implement it. So we comply, and here we have draw as defined for a circle, just as it was in previous classes, and we have the fully overridden toString method. You can see here we actually do call, as part of it, super.toString, which calls abstract shapes toString as a part of the string we're building here. We also have wheel. Wheel, just as before, extends circle, and we add a new instance variable spokes. Everything else looks the same as it did before. We have our constructors, our draw method, which invokes super.draw. In this case, think super refers to the immediate superclass of wheel. So in circle, super referred to abstract shape. In wheel, super refers to circle. So we call circles draw method, and then we just add on the spokes. Finally, we have our methods set spokes, which is specific to the wheel class, and toString, which we override completely. Finally, we have our class for rect. We've made all the important points in circle and in wheel, but we can see here it does extend abstract shape. We call super a number of times to refer to abstract shapes constructors. And here you can see in the toString method, we call super.toString to refer to abstract shapes string method, which we incorporate into the string we're building here. Again, big idea, any methods that were defined as abstract in an abstract class must be implemented in subclasses, and we comply with that with draw and stretch by in rect and circle. Big takeaways here. What's an abstract class? Give me an example. Why do we declare abstract methods? What's a situation in which we might do that? What is a final method, and what does the keyword final do if we declare a method to be final? And what's a protected variable? That's just a review right there. That's it for today and abstract classes.